Hi there, Mr. Sutton here, bringing you the Pre-Cal Honors 2-7 Part 1 homework solutions on applications of polynomials. For number 1, we have one of these fold-up, cut the squares out of the corners box problems. The piece of cardboard we're starting with is 12 by 18. So we need to figure out the size of the squares that give us the maximum volume, the domain, a formula for the volume, maximum volume, all that stuff. All right, so let's come up with some ways of expressing the different dimensions of our volume. So in general, we can express the length of these squares as x. That's what we have control over. And that doubles as the height of this box once we fold up these sides. Next, this side over here, once we cut out these squares, each of which has a length of x, we're left with 12 minus 2x for this side. This will be, I guess you could call this the length of the box. And then the width, which we get by folding up this other dimension here, that's going to be 18 minus 2 of these x length squares. So our volume then, in general, length times width times height, we're going to have 12 minus 2x times 18 minus 2x times x. And then for the domain, first we need to figure out the zeros for these, the places where the dimensions run out. So for this first one, we've got 6, and then 9, and then 0. So our domain, well, obviously we have to have a side length, of a height of more than 0, but we also want to make sure we don't run out of either of these sides. This 12 minus 2x side is going to run out first when you hit a value of 6 for x. So our domain then is all the numbers between 0 and 6. In between those numbers, we get real boxes. Outside of those numbers, we either have a negative height or one of our dimensions runs out. Next, we're going to do f max of this volume function on our graphing calculator, and we're going to use 0 and 6 as our interval. So if you go to the math menu, f max, I plug this into y1. So whatever your function is, put it in, then a comma, then x. Then we'll do 0 and 6 for the domain. Let me show you that all. So I've got my function that I entered in y1 just to make my life a little bit easier. And part of the reason I entered this in y1 is I'm going to want to go back and plug in the best value of x for this anyway to get the volume. So quitting out of that now, I'm going to go to my math menu, and then I have to go down to fmax, option 7. I'm going to go with y1. To get there quickly, I'm going to do alpha trace, and that brings up this little menu where I can quickly get to my y1. You could also go through vars. Then I'll do a comma, x, comma, and then I need to put the domain 0 and 6 that I'm looking in. So 0, comma 6, close the parentheses if you want, and that gives us a value of about 2.35. Now this was in inches, so that's the length of the squares that we want. Our max happens when our squares are at about 2.35 inches. Now to get the actual volume, we're going to go back to the calculator, and I'm going to plug this answer that I just got into y1. So again, alpha trace, call up y1, and now I'm going to open a parentheses here, and I can use this like a function. So I'll do second, and then this little minus to give my last answer as the input here. Plugging that in, I get about 228.16, and that's going to be cubic inches, because this is volume. For number 2, we've got a rectangular piece of cardboard that's 80 by 120 centimeters, cutting out squares from the corners and folding up the sides to make a box without a lid. So we want the formula, the domain, size of the squares, and the maximum volume. So let's start with a picture. We have x as the length of the squares. That's also the height of the box. And then this side here, this is going to be 80 minus 2x, because we have 2 of these x length squares. And then this longer side we'll call 120 minus 2x. Volume in general for a rectangular prism, length times width times height. So that's going to be 80 minus 2x times 120 minus 2x times the height of x. So there's a formula for volume. Now to get the domain, we're asking basically where does one dimension of this run out. So we don't want to have a height of 0 or less, so x has to be greater than 0. And if x is too big, we're going to run out first of this 80 minus 2x side. So if x is 40, we run out of this side. Not a bad idea in general just to find the zeros of this real quick. So we've got 40, 60, and 0. And then the domain is just going to be 0 to the smaller of those other two zeros. So 0 less than x less than 40 is our domain for this. Okay, let's go ahead and plug this into fmax on the calculator now. So here's the general setup. If you've got your function, your volume function entered in y1, you can do fmax y1 comma x comma domain values 0 and 40. Let me show you on the calculator. So I'm here in my y equals at y1, and I've entered the whole function in here. I'm going to use it a few times anyway. Quitting out of all that now, going to my math menu, option number 7, fmax. Let me do alpha trace to get my y menu here. We'll put y1 in as the function, comma, it's always x next, and then our two domain numbers, 0 and 40. Enter. So that gives us the maximum at a square length of 15.69 centimeters. Next, we're actually going to plug that into the y function, or the volume function, to get the volume. So back on my calculator here, I'm going to do alpha trace again to get y1. Open a parentheses, and I'm going to do second and then answer down here to just plug in this answer I got for my volume function. That gives me a big number, about 67,603.58, and that's going to be cubic centimeters. For number 3, a box with no top is being built by taking a 6 by 10 inch sheet of cardboard, cutting out squares from the corner, like so, and folding up the sides. We want the dimensions of the square that yield the maximum volume. So for this one, we've got x as the length of the squares. 6 minus 2x will be this length side here on the top. And then 10 minus 2x will be this other side. For the volume formula, which we need to find the dimensions that maximize the volume, we've got, in general, length times width times height. In particular, we have 6 minus 2x times 10 minus 2x times the height of x. Let's go ahead now and find the zeros and the domain for this thing, just so I know what to plug in my calculator. Zeros, we've got 3, 5, and 0. So my domain is going to be going from 0, 0 or less, and I've got no height, to the smaller of these two values, 3. Once I get to 3, I run out of this top side here, so I have to stop right before I get to 3. And now let's plug all this in our calculator. So we've got fmax of the volume function here, comma x, comma domain numbers 0 and 3. I'll show you on the calculator now. So here we are in y equals. y1 is going to be that volume function I just came up with, right here. And then I'm going to quit out of here now and go to my math menu, option 7 for fmax, that's function max. Let me do alpha and then trace to get my menu with the y1 on it. I've stored my function in y1, and I'll do comma x, comma, we want the domain values 0 and 3, so 0 comma 3, and that comes out to roughly 1.21, and that's going to be in inches. For number 4, we've got an open box being made from a 16 by 30 inch rectangular piece of sheet metal, cutting out congruent squares in the corners. So we want to know the size of the squares that yields the maximum volume. Let's start by writing a formula for the volume. We've got the size of the squares, x, which is also the height of the box. We've got this length side of the box, which we can get by doing 16 minus 2 of these x length squares. Then we've got the width of the box, found by doing 30 minus, again, those 2x squares. Volume in general, length times width times height. So that's going to be 16 minus 2x times 30 minus 2x times x. We're going to plug this in our calculator now. Before we do that, though, we need to find the domain. We need to know where to tell our calculator to look for the max. So I've got my zeros of 8, 15, and 0. The domain of this thing, I don't want to look outside of 0 and 8. At 0 or less, I've got no height. At 8 or more, I've lost this dimension of the box and eventually this other dimension. So our domain is 0 to 8. They didn't ask for it, but it's helpful. Plugging this in our calculator now, we've got the volume function, comma x, comma domain numbers, and I'll use fmax for this. Let's go to the calculator now. So here we are in y equals and y1. I'm putting my volume function there. Quitting out of this now, I'm going to my math menu, fmax, option 7. We'll do alpha trace to get that y1 function from this menu, comma x, comma 0, comma 8, because those are my domain numbers. And that gives me 3.33-ish, and that's going to be in inches.